going to talk about the other kinds of discontinuity. So the first one we're going to talk about is point discontinuity. And a point is exactly that. It is a point. So that means it's going to have an x and a y. And it only comes from a canceled term. So it has to come from a canceled term. If you don't cancel, you have no discontinuity, no point discontinuity. So on the first one, I want to know if anything cancels. So on top, I just have an x squared. And on bottom, what can I factor out? Yes, the 3x. So if I take out the 3x, that leaves me with x minus 2. So what can cancel now? One of the x's on the outside of the parentheses. So this x will cancel, and I only have one left on top. So I canceled one x. So I'm going to set that x equal to 0. And my reduced function now is x over 3 times x minus 2. So to find the point discontinuity, I'm going to take this 0, and I'm going to put it in the reduced function. So I get 0 over negative 6, which equals 0. So my point discontinuity is 0 from here, and this is the y value for the point discontinuity. So for number 2, if I factor on top and factor on bottom, does anything cancel? The x minus 3 cancels. So I'm going to set that equal to 0. That's my canceled term, and that goes equal to 0. So then I'm going to write the reduced function down, which is x plus 2 over x plus 3. So my x equals 3. So I'm going to take the 3 and put it in the reduced function. So my point discontinuity is going to be at 3 and 5/6. So on number 3, on top, if I take out a 2x, the 2x's cancel, so I get x minus 3. I canceled the 2x, so I have to set it equal to 0. So when I divide by 2, my x is 0. So I'm going to take the 0 and plug it back into my reduced function. So my point discontinuity ends up being 0 and negative 3. We are going to graph, but not today. So that's how we find the point discontinuity, only from a canceled term. And it's an actual point. Okay? So next, we already talked about the vertical asymptotes. That comes from the denominator. So first of all, I want to save everybody here some grief. Can I cancel those x's? No. Only if you want to get punched. You cannot cancel these x's. Okay? So nothing cancels, so I don't get a point discontinuity. So from here, though, I can get a vertical asymptote because that comes from the bottom. So we get x is a negative 2. So on number 2, do I get a vertical asymptote at x equals 7? Why not? Because I'm going to factor and cancel. So this is x plus 7, and x minus 7. The x minus 7 cancels. It's a canceled term, so that tells me for sure I get a point discontinuity. It's at 7. This is my reduced function. So if I take the 7 and put it in, so my point discontinuity ends up being 7 and 14, but no vertical asymptote because there's nothing left on bottom now. So number 3, I'm going to go ahead and factor. So this time, I do have a canceled term. So that tells me for sure I have point discontinuity. And when I cancel, I still have the x plus 4 on bottom. So that tells me I also have a vertical asymptote. So my vertical asymptote is at x equal negative 4. And you have to write it with the x equal. Don't just put negative 4, okay? You have to have the x equal. And so here, the x is positive 4. So I'm going to substitute that in my reduced function to find the y value of my point discontinuity. So my point discontinuity is going to be 4 and 1/4. No. I got negative 4 from the bottom here. Right here. No, you said here. X minus 4 gives me a positive 4, not a negative 4. I heard what you said. It comes from here, though. Okay? All right. So, number 4. Is anything going to cancel? If nothing cancels, I don't have any point discontinuity, so what are my vertical asymptotes? X equals 0 and x equals negative 5. Okay, so we did point discontinuity and vertical asymptotes. So the vertical asymptote is up and down, right? So now we're going to talk about the horizontal asymptote. If the board will ever change. I know. Nothing's working. Okay, so horizontal asymptote. So the horizontal asymptote goes this way. So it's a line, and it's y equals. So it's a line, and it's y equals. So we're going to have 3 kinds of horizontal asymptote. First of all, if the degree on top is bigger than the degree on bottom, there is none. So if the degree on top is bigger, then there is no horizontal asymptote. So here it's 2, and here it's 1. So the top is bigger than the bottom, so this is none. Or no horizontal asymptote. So here, the 3 is bigger than the 2, so there is no horizontal asymptote. If the degree on bottom is bigger than the top, so if it's exactly the opposite, it's going to be y equals 0. So here, 2 is bigger than 1, so this is y equals 0 for my horizontal asymptote. So here I have 1. How many x's do I have on top? None. So that means the horizontal asymptote here is y equals 0. So on top is none, on bottom is y equals 0. So if it's tied, so if the degree is the same, so here I have 2 over 2, I'm going to use the leading coefficient. So I'm going to get y as 1. Here I have 1 and 1, so I'm going to use the leading coefficient. So I get y is 2/5. So on top is none, on bottom is y equals 0, and if it's tied, it's the leading coefficient. Okay, so there's one more kind of asymptote, and it's a slant asymptote. So, and that's exactly what it sounds like. So vertical is up and down, horizontal is this way, and slant means it goes like this. Like it looks like a line, and it's in y equals mx plus b form. So first of all, let's look at number 2 and 3. When you get one and there's only one term on bottom, we're just going to divide. Well, we're not even going to do this one. Do number 3. So this is one bigger. It's one bigger. So it's going to have a slant asymptote. If it has a slant asymptote, it has no horizontal asymptote because it's top heavy. Okay? So I'm going to have 2x squared over 2x. So when I get that, the 2's cancel, and I get 1x. 4 divided by 2 is 2, and the x's cancel. So this is my slant asymptote. And we don't care about the remainder. Yes, me too. So the slant asymptote is y equals mx plus b form. So if you start with one term, you just divide each of them by that one term. Okay? So if it's like the top one, we're going to synthetic divide. So do I synthetic divide a positive 2 or a negative 2? Positive 2. So this is what you get. And what did I say? Do we care about the remainder? We don't care about the remainder. So this started as x squared. So this one is, so my slant asymptote is y equals x minus 2. And that's if there's no leading coefficient or no exponent. But how do I have to do number 4? No. Okay, if we can't synthetic divide, what's the only other division we know how to do? Nope. We're going to long divide. Well, this is easy. I think so. Okay, divide. I still have to divide the first term by the x squared. And so once I get the minus 8, do I care about anything after that? I don't. So you don't even have to finish it. This is all I needed. So my slant asymptote